We've been working with square roots, right? So you can take the square root of 49, right? That would be 7. But what if you had the square root of negative 49? Well, you know what? That is not a real number. So we're just going to say not real. I just want to go over that because now we're going to talk about other types of roots. So let's say you have a cubed equals 8. So what we're saying is there's some number out there times itself, you know, a, that would equal 8. And there is 2. 2 to the third power is 8. 2 times 2 times 2 is 8. So back up here, if you're trying to find a, you're saying what is the cubed root of 8? And the cubed root of 8 is 2. All right, so now they're not necessarily square roots. If you have a radical symbol and there's no little number here in the radical, then it's a square root. But this would be a cube root, and that little number is called an index. Okay, so it's an index on the radical. So if they have, you know, the cubed root of 27, and you might say, well, I don't know the cubed root of 27. What I would say is break it down into what you know. 27 is 9 times 3. 9 is 3 times 3. Okay, now, when we did that circle thing with square roots, and we said, oh, if you have a pair, you get one out. Well, since it's a cubed root, you have to have a group of 3 to get one out. So the cubed root of 27 is 3. And you could use that idea for others. Let's say you have the fourth root of 16. Well, 16 is 4 times 4, and 4 is 2 times 2, another 2 times 2. So you'd have to have a group of 4, but you do. So the fourth root of 16 is 2. Okay, but that's the idea we're going with here. So you're not necessarily going to have a square root. You could have a different index. You could have a cubed root, a fourth root, a fifth root. They go higher, but, you know, let's see what we have. All right, we're going to simplify nth roots. By that, nth roots, we're saying, well, it could be a cubed root, it could be a square root, some kind of root. All right, so we want to do the fifth root of negative 32. By the way, now if you're thinking, oh, she just mentioned that. Yeah, but you can take a fifth root of a negative number. So if your index is odd, an odd number like 5 or 3 or 7, you can have a negative radicand. But if it's even, then you can't. Okay, now what's 32? Well, it's negative 2 times 16, I guess you could say that. But it's all going to simplify. It winds up being negative 2 times negative 2. There's 5 of them. I'm going to run out of room here. All right, and since you wanted a fifth root, the answer is just going to be negative 2 here. And if you put that on a calculator, negative 2 times negative 2 times negative 2, you know, 5 of them, you would get negative 32. All right, this next one is a fourth root. Well, you've got 1024 here. Now, I could see if 4 goes into 1024. Let's see if it does. 1024. So this is old-fashioned division here. Oh, my goodness. 256, right? So I get the fourth root of 4 times 4 times 2, fourth root of 256. Okay, but I bet you 4 goes into 256. How many times? 64. And 4 goes into 64 16 times. Okay, well, that's nice. Now look, I've got a 4 here, a 4 here, a 4 here, and a 4 here. That's a group of 4s. I'm going to write this a little bit better. But what about that 16? Well, that's 4 times 4. That's true. But let's write this. But we'll put it all in terms of 4. Okay, so you have the 4th root of 4 to the, let's see, 1, 2, 3, 4, 5 of them. Okay, so the 4th root of 4 to the 5th. Okay, wait, did I miss one? 1, 2, 3, 4, 5, 6. Sorry. 6th power. So that's 1 4 on the outside. And then you have 4 squared. You'd have 2 left over. But 4 squared is 16. It's kind of a long way to do this problem, probably. And then we just did that a minute ago. 16 was 2 times 2 times 2 times 2. So you're going to get 4 times 2, which is 8. Now, another way you could have done it, you could have just multiplied 4 times 1024. Then you'd have to figure out, well, what does that break down to? I guess it's 8 times 8 times 8 times 8, 8 to the 4th power. That one was kind of hard. I like to keep my numbers small, so that's why I went with the 4s. And then I would have had to recognize here, though, that the 16 would break down. That was my concern. Okay, now, the next one is a cubed root. Notice that you have a negative sign on the outside. That's fine. The negative can be on the outside. That's fine. And then what are we going to do inside? Well, we could split this up into the cubed root of 8x to the 6th over the cubed root of 125. Now, in the numerator, we've already done 8. We said the cubed root of 8 was 2. And then how will you deal with x to the 6th? You could think of it as 6 little x's, being multiplied together, or simply divide the index, 3, into the exponent, and it goes 2 times. So it's going to be x squared. All right? Now, what's the cubed root of 125? You're probably guessing that it's 5, and it is. So that's the answer. It's negative. So negative 2x squared over 5. All right, let's see, we've got another one here. Now I've got the 4th root of 3. That's not going to simplify. But what about the 48? Well, 48 is 3 times 16. And we did the 4th root of 16. We've done that a couple times. Now you could write that out like this. Is one way you could write it. Whenever you have a 4th root or a cubed root where the index is not 2, not a square root, you have to make sure you always put the index, okay? Otherwise, it's going to look like a square root. Okay, so I have 8, 4th root 3. But this, we've already done that a couple times. The 4th root of 16 is 2. 4th root 3. Oh, it's subtraction, though. But look, the radicals are the same. So you can subtract 8 minus 2, 6, 4th root 3. And is that the last one? I think so. Yeah. All right.